Hello, let's continue our Sudoku adventure with German Sum by SennyK. And this is SennyK's debut. Welcome to the team, SennyK. I'm sure there's great things ahead for you. All right, so everyone give a warm welcome to SennyK in the comments. All right, let's go over the rules. We have normal 6x6 Sudoku rules. So in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have German sums outside the grid. So this means that starting from the first cell next to the clue, we're going to include digits in the sum until they stop being valid German whisper lines, basically. So until the adjacent digit is less than 3 different from the one before it. So let's give a concrete example here. So in the rules, we have 2, 6, 3, 1, 5, 1, 5, 4. So starting from here, we always include the 2, no matter what. So we're going to include this one. And then the 6, if we do 6 minus 2, that's a difference of 4. So we do include that. Then if we do 6 minus 3, you always just do bigger minus smaller. So 6 minus 3 is 3. That is at least 3, so we include that. But now this 1, 3 minus 1 is 2. That is not at least 3, so we stop. And so then we sum all of the ones that did follow the rule, and they sum to 11. And so that would fulfill this clue. Now, if we work from this side here, the sum would just be 4 because 5 has a difference of 1. That is not at least 3. So we'd stop right there. So on this side, if we had a clue, it would be a 4. Hopefully that's clear. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. I'm noticing a 21. 21 is a special number in 6x6 because the sum of the digits 1 to 6 is 21. So I know something about a German whisper line that takes up an entire row, column, or box, which is that it resolves in only 2 different ways. Now, I can prove that, and this is kind of how you would approach thinking about that anyway. So the first thing you want to think about are 3s and 4s. 3s and 4s are very special. If I tried to put a 3 here, and I know this entire thing needs to have a difference of 3 between each cell in order to sum to 21. So if I have a 3 here, then this would have to be at least 3 different. Well, the 6 would work, but this would also have to be 3 different, and 6 is actually the only digit that works next to a 3. 1 through 5 are all too close, and so this would also be a 6, and that would repeat the 6 in the column. So 3 has only one buddy, so it can't go anywhere except here or here, and 4 has the same issue. Its only buddy is the 1. And so the 4 has to be here or here, where there's only one place to put its buddy. So this is going to be a 3-4 pair. Now, next to 3 and 4, we always have to put 1, 6, and then the remaining 2 digits are the 2 and the 5. So this is either going to be 3, 6, 2, 5, 1, 4, or the other way around, 4, 1. Sorry, it would be the same digits, but upwards, right? Okay, so now this 11 is a 2 or a 5. Wonder what we can do with that. The 6s. Okay, so normally I would say you can add to 6 in 3 cells. 1, 2, 3. But there's no way that fulfills our German sum requirement. So we can't actually do that, meaning that the 6 can use up to 2 cells, which means this could be a 6 on its own, or we would do 1, 5. And I think that would be, or 5, 1. And I think that would be the only option, because if we tried to do 2, 4, that has a difference of 2. So this is either a 6 here or a 1, 5 pair here. And this is the same. Now I can pencil this one because this one's always involved with the sun. I can't pencil this one because I can't say this is like 1, 5 pair because that's not true. Unless, one of these is a 1, 5 because they can't both be 6. So one of these is a 1, 5. There's definitely a 6 in one of these two. Those are the only 2 ways to do it. Although I suppose we could do 1, 5 here and 5, 1 here. That's actually possible. So never mind. We don't have to use the 6. But we still definitely have a 1, 5 in at least one of these two. All right, what else can I look at? The 9. 9 you can do in 3. Or 2. You can't do it in 1. Now, let's see. How would we do 9 and 2? 3, 6 would work, but we can't do 4, 5. So if we were doing 9 and 2, it would be a 3, 6 pair. Now 9 and 3 is interesting. So something I know about summing 9 and 3 is you always need exactly 2 cells from 1, 2, 3 and 1 cell from 4, 5, 6. So 2 cells from 1, 2, 3 in some order and 1 cell from 4, 5, 6. Why is that? Well, if I tried to do all 3 to be 1, 2, 3, we would sum to 6. That isn't 9. If we tried to do 2 cells from 4, 5, 6, notice that the smallest of these two, 4 and 5, would already add to 9. So this would be too much. And so we need exactly 2 of 1, 2, 3, and 1 of 4, 5, 6. And in order for these are never going to be 3 apart from each other. 1 to 3 is at most 2. So the 4, 5, 6 has to go in between them. And it's never going to be the 4 because these would both be 1. So we are not 2, 3, 4. If we involve the 3 at all, we have to use the 6. But the problem is 6 plus 3 is already 9. So we're not going to involve the 3. So this is a 1, 2 pair, which means we must use the 6 to get to 9, but only if we do it in 3. So this is what it would look like if it was 9 and 3. If it was 9 and 2, it would be a 3, 6 pair. You can't do 9 and 4 because the minimum of 4 cells is 10. 1, 2, 3, 4. And that's not even the minimum because that doesn't follow the German whisper rule. So, that there's always a 6 is kind of my conclusion. There's always a 6 involved. This is from 1, 2, 3, 6, but the important thing is that we either definitely have a 1, 2 pair here with a 6. Oh, okay. Actually, I can prove that it's not 1, 2 pair with a 6 because 1, 2 pair with a 6, the 6 removes the 6 from here and the 1, 2 pair removes the 1. So that's not going to work. So actually we have to be a 3, 6 pair, which then gives us the 1 here. Now that tells us the order this goes in. That's 4. The 1 goes next to 5. That's 2. That's 6. That's 3. That's not the 6. That does not mean this is the 6 because we could do 2, 1, 5 pairs. So we got to be careful there. Now this is a 2 and we got to get to 11. So we got to keep going. And so next to 2 is a 5 or a 6, but the 5 is taken. So that's a 6. Now that adds to 8. So we have to keep going. And this is a 1 or a 3. 8 plus 3 is 12. That's too big. So no, 8 plus 3 is 11. That's perfect. Right, and so if I tried to do a 1 here, we'd end up too big because I'd have 1, 2, and 6. I already know that to get 11 and 4, the only way to do it is 1, 2, 3, 5. But even with this alone, and without that logic, 1, 2, and 6, we need to include at least a 3, but actually we'd have to include at least a 4 because of this German sum. And that's already going to add to 13. So this does end up 3. And then now we have to end here. So we have to be close enough to 3. We have to be a 1 or a 4 or a 5. Basically just not 6, but there's already 6 in the row. This is just 1, 4, 5. So I guess that doesn't really matter. This is 1, 4. This is 2, 3, 6. All right. So this will just end no matter what. We were never going to do 6 and 3. And 3 is a very viable one to end our and our sum, so that doesn't help too much. 3, 6 pair here, does that help us? This is a 14. Maybe we should think about that. So minimum cells for 14. I suppose now is a good time. I probably should have talked about this a long time ago. If you're not familiar with the German whispers, which is what this is based on, we have to alternate low, high for our sum. Why is that? Well, when we're in the 1, 2, 3 range, next to that, to keep going on our sum, we can't stay in the 1, 2, 3 range. We already kind of talked about that with the 9. Because that has a difference of at most 2. And so we have to move up to the 4, 5, 6 range. Once we're in 4, 5, 6, we have to move back down to 1, 2, 3. So we actually, every other one is going to be the same low or high as each other. So we have to alternate low, high is my point. So if we want to think about the minimum that 3 cells could add to in kind of a heuristic way is to think, well, the minimum would be 2 lows and 1 high. And so that would be 1, 2, 4. But then if you think about that, 1, 2, 4 doesn't actually work because the 4 can't be next to the 2. And so we'd actually end up with 1, 2, 5 as our minimum, which is 8. So just things to think about. And so the minimum for 4 digits is 2 lows and 2 highs. And I think I could do 4, 1. Let's just say I could do a 1, 2 pair with a 4, 5 pair. That'd be 9 plus 3. That'd be 12. Okay. Is the question more that can I get to 14 and 3? I know I can't do it in 2. Can I get to 14 and 3? The absolute maximum will be a 5, 6 pair with a 2 in the middle, which is 13. Okay, so I think that's key. And also the middle cell can't be 2 anyway. And 3 doesn't work. Okay, I think this is the easiest conclusion, actually. 3 doesn't work here because it can't be surrounded by 2 digits that would work for the sum. And so we'd use this sum and this sum at best, and you can't get to 14 and 2, especially with the 3. And so this has to be the 6. This is the 3. All right. Now, the 6 is surrounded by a 1, 2, or 3. This can't be 3. So the biggest this could add to is 2 plus 3. Oh, but then, okay, yeah, so let's just take this one step at a time. Biggest this could add to is a 3 here and a 2 here, which is 5, plus 6 is 11. That's not 14 yet, which means I can't actually use a 3 here because the 3 wouldn't be able to continue. It already has its 6 on this side. So this has to be the 2, which makes this the 1. Now that's 6 and that's 3. And now we know this is 4 or 5, and we know we need to continue the sum. So 4 would not continue it next to the 2, so we have to use the 5. Now this adds to 11 plus 3, that's 14, so now we stop. And so the digits remaining are the 3 and the 4, either of which would stop the 5, but we actually know the order. That's 4, that's 3. Now this did end up not being a 6. I'm glad I didn't use that logic of it one needing to be 6 because that was wrong. This 6 now, the 6 in this box now ends up here. I do have this 6 here. Okay, so these are both 1, 5 pairs then. What's going to resolve our 1, 5 pairs? I'm a little concerned about that. This is 4, this is 1. This is 4, this is 1. It does make me wonder if there was another option besides a 1, 5 pair. I don't see how. This is a 2. It's just I don't know how this is going to get resolved. Oh, it's probably resolved by these guys. Yeah, it is. So if this was 5 and then 1, the 1 is far enough away from the 4 that we have to include the 4 in the sum as well. And then we wouldn't sum to 6. So this is 1 and this is 5 and this is 5 and this is 1. All right, this is a 2. This is a 4. This is why uniqueness is really dangerous to use in variance if you're not 100% sure. Anyway, this is 2. This is a 4, 5 pair. So that's 5, that's 4. And the remaining digits. Okay, so this needs 2 and 5. That's 5, that's 2. And this needs 3 and 6. 6, that's 3. Is that not our solution? Uh-oh. So, yeah, it is not our solution. So what did we mess up? This is going to add to 3, 6, 2, 5, 1, 4. That adds to 12. 1, 5, end at the 3. That adds to 6. 5, 1, end at the... Oh, I completely swapped the... I did it wrong. Sorry. There we go. I gave the entire logic of why it had to be one way, and then I did it the other way. Sorry. Okay, easy enough fix. I knew what it had to be. I just typoed it wrong. Cool. Well, that was a fun puzzle. Nice debut, SennyK. Seems like an interesting rule set. I don't know if you invented it or not, but you certainly used it well. Let me know how you did, and if you enjoyed this, why not leave a like, subscribe, and a kind comment below.